Hello, this is Rodolfo Gomez, and this is my demo video for the rendering engine for GAM475. As you can see here, we have a variety of primitives here. So some of the features that I got working for this demo are we have 4 primitives. We initially have 4 primitives. This is the cube, pyramid, sphere, and then if we go all the way in the back over here, we have the cylinder. So this shows that we have we support about 4 types of primitives for this rendering engine that I made. And I'll go down the list of the stuff that I have working on here. So all the primitives on here, they're all loaded from a separate file. The cube has its own file, it's its own vert data. The pyramid, it has its own vertex data loaded from a file also. Same thing with the sphere and the cylinder. As you can see earlier, I have multiple cameras supported for this, and you can also move the camera around. You cannot really translate the camera, but you can rotate the camera around an object. I usually have it centered in the center of this demo field for each type of primitive. And then all these cameras are controlled by a manager in a bucket sort of thing, in a W link list. And then they can be changed on the press of a button. Just showing you how this thing moves around here. So the amount of shaders that is supported for each primitive object, we have about, we could support textures in here. You have duckweed, rocks, and brick. Also, we have other types of shading modes. We have wireframe, and then the default shader we started out with in the class, and then this one is you can also do lighting calculation stuff for shaders. So they have normals and stuff also. So we can do constant diffuse lighting, and also we can do diffuse lighting on the texture object, on textures also. Another feature that I have is that we can switch the textures on an object. So press F1 here. This one switches, so is rocks. Now it's stone, duckweed, and brick. The way the switching is kind of finicky. I haven't really found a way to do a get button up thing for GLFW. It only works with getting a button down itself. And also you can swap the texture on this one here for the diffuse texture calculation stuff. So it still goes through still supports the same texture files that are loaded in. All the textures themselves, they are also loaded in from a file using the Targa format. Using the example that was in class. And all the objects seen on here, they're all rendered using the parent-child sibling tree or the PCS tree. So they are essentially in a very quick and dirty hierarchy. These are all attached to a single root node using the null object design pattern. And also for the texture stuff, these are all managed with a manager. And also the way I switch camera, I think I explained it earlier, but all the cameras that we have here in the scene, they are also managed by a manager. And also to show some of the, it's not just green and yellow this supports, we can also do red. Because it's just a color that we can set in code and not through the shader file itself. And also we can swap texture on any kind of primitive. So this works on the also works on the pyramid too for swapping textures. And also on the sphere too. So the way all of this is constructed, it is constructed using instancing. So we have a single pointer to a game object, and then we just call it through in the code here. Yeah, try to make this a little bit bigger. So here we have the this is all the graphical stuff for whatever shader we want to use, and then here's our game object pointer, and then through here using these this stuff up here, we do the instancing through here. This commented out stuff here is just for experimenting, for adding to a parent. I haven't really gotten that stuff working. Yeah, it just follows this through here and it does everything that we this just demonstrates the instancing stuff that's required for this demo. So some of the stuff that's not working for this demo is can I really create a game object on a button press, and we cannot really generate a camera on in real time also, and we cannot remove game objects and camera in real time. And the way it is doing OpenGL, when the rendering for the stuff in OpenGL is not really doing it through advanced optimization techniques. This is just a quick and dirty way of sending data through to the GPU. So, yeah. That should be it for this demo. In the next class, we will hopefully get a complex model implementation and reading animation data.